Ever wonder what happens to chemicals, after they've served their purpose? We use what we need and then poof, gone, right? Well, today's deep dive might have you thinking twice about that. We're going to be looking into the legacy of chlordecone. It's a pesticide used in the French West Indies and chlordecone. Well, buckle up. This story takes us on a journey through soil, time, and the true meaning of long-lasting impact. Hmm. Our guide today is a scientific study from 2009. It takes a hard look at how long this chemical might stick around in the environment. And, spoiler alert, the answer is a lot longer than anyone would like. To help us break down the science, we have our expert with us.
It's great to be here. Chlordecone is a fascinating, albeit troubling, case study. It really shows how environmental persistence can really throw a wrench into things.
So let's start with the basics. What exactly is chlordecone, and what was it doing in the French West Indies in the first place?
Chlordecone, sometimes called ketone, is a synthetic. It's a synthetic organochlorine insecticide. It was used pretty extensively in the French West Indies, particularly on banana plantations, to combat the banana weevil.
Sounds like a pretty effective pesticide if they were using it for that long.
Yeah.
What's the issue then?
Well, the issue is that while it was good at controlling the weevil, it didn't just disappear after it served its purpose. It stuck around and stuck around. And as we'll find out, it's predicted to stick around for a very, very long time. This persistence is largely due to its chemical structure, which unfortunately makes it slow to break down in the environment.
Okay, so this isn't your average garden variety pesticide. This isn't something that degrades after a season or two. This stuff has staying power. What makes it cling to the environment for so long?
It really boils down to how chlordecone interacts with the soil. The primary way it's removed is through a process called leaching. It's where rainwater essentially washes it away. However, chlordecone has a strong affinity for certain components of the soil, particularly something called soil organic carbon, or SOC.
SOC.
Yeah, the more SOC present, the more tightly chlordecone binds to the soil, and that makes it less likely to leach away.
So imagine you've got this chemical and it's clinging to the soil and
Hmm.
rainwater is trying to wash it away. If the soil has a lot of organic carbon, it's like the chlordecone is holding on for dear life.
Exactly. And to really understand just how tenacious chlordecone can be, we need to look at the specific types of soil it's hanging out in. The research paper focuses on three main types found in the French West Indies: andesol, ferrule sol, and netasol. Each of these has a different capacity to hold on to chlordecone.
So it's not a one-size-fits-all situation. The type of soil really matters.
It makes all the difference. The study uses a measure called the Soil Carbon-Water Partitioning Coefficient, or CUCIC, which essentially tells us how sticky the chemical is to soil particles. A high COC value means the chemical binds tightly, leading to longer persistence. And when we're talking about chlordecone in certain soils, those COC values, well, they paint a pretty alarming picture.
Okay, now you've got me on the edge of my seat. Let's dive into these soil types. Tell me more about this chlordecarc value and what it reveals about chlordecone staying power in each of them.
Okay, so different soil types, different levels of clinginess. Let's break them down. You mentioned this Codacog value. What kind of numbers are we talking about, and what do they mean for how long chlordecone sticks around?
Right, so the Codacov value, it gives us a way to quantify this stickiness. The higher the Cotoc, the stronger that bond between the chemical and the soil. Andesol, for example, has a really high Cotoc for chlordecone. This means it binds very, very tightly to the organic matter in the soil, making it extremely difficult to remove.
And just how long are we talking about here? How long does this stickiness keep chlordecone hanging around in andesol?
Well, the study's model predicts that chlordecone could persist in andesol for centuries, potentially even up to 500 years.
Centuries. That's longer than the United States has even existed. Yeah. It's a staggering amount of time, and it really underscores the importance of understanding these long-term consequences, especially, when we're talking about chemical use.
Absolutely. So andesol is like the super clingy soil. What about the other two?
So ferrule sol, the second soil type, has a lower Kachuk for chlordecone compared to andesol. This means that, while it still holds on to the chemical, the bond isn't quite as strong. In this soil, the model predicts persistence could be on the order of a few centuries. Still a significant amount of time, but a noticeable difference from the andesol.
Okay, so we've got centuries for andesol, a few centuries for ferrule sol. That leaves us with netasol. Is there any good news there?
Netasol has the lowest Kachuk value of the three for chlordecone. It still binds to the soil, but the bond is much weaker. As a result, the study suggests that contamination in netasol could potentially clear up within decades.
Decades. Okay, that feels almost manageable compared to what we're talking about with the other two soil types. It's still a long time, but it does offer a glimmer of hope.
It does, but there's a catch. While Nudisol might release Chlordecone faster in the long run, this can actually lead to a higher risk of water contamination in the short term.
Wait, why is that? I thought a weaker grip on the chemical would mean less contamination overall. Help me understand this.
Okay, think of it like this. When Chlordecone is really tightly bound to the soil, like it is in anisole, it's less likely to leach out with rainwater. But with a weaker bond, like in nittisol, the chemical is more readily released into the water that moves through the soil. So while it might eventually clear out faster, in the meantime, you could see higher concentrations of Chlordecone in water sources.
So it's a trade-off. Slower release, but longer persistence in the soil. Or faster release with a higher risk of water contamination in the short term.
Precisely. And this is where the real-world implications of this research become even more apparent. We're not just talking about contaminated soil, we're talking about potentially contaminated drinking water and food crops, which obviously has, huge consequences for the people living in these areas.
This is what makes this whole thing so much more than just an abstract scientific study. This is about people's lives, their health, their livelihoods. It must be incredibly concerning for the communities in the French West Indies who are dealing with the legacy of Chlordecone contamination.
Absolutely. And the challenges go beyond just the science of it all. The study also touches on some of the difficulties in remediating contaminated soil, especially given the agricultural practices that were common during the period of Chlordecone use.
Let's talk about that. What makes remediation so challenging in this case? What are we up against?
One of the biggest hurdles is linked to a practice called deep tillage. For years, it was common practice to, turn over the soil to a significant depth. While this can be beneficial for some things, in this case, it really exacerbated the Chlordecone problem.
How so? It seems like turning over the soil would be a good thing. Kind of like airing it out, right?
You might think so, but with a contaminant like Chlordecone, it's more like taking a spill on your countertop and wiping it around instead of wiping it up. Deep tillage spread the contamination further down into the soil profile, making it that much more difficult to remove.
So instead of being concentrated on the surface, it's now spread throughout a larger volume of soil. That sounds like a real headache for remediation efforts.
It certainly complicates things. And the implications of all of this, the persistence, the contamination of water and crops, the challenges of remediation, it all comes down to the people living in these areas.
This is where the story of Chlordecone goes from a scientific curiosity to a real-life human issue. What are the long-term consequences for these communities?
Well, the impact on agriculture is significant, especially for the banana industry, which is a vital part of the economy in the French West Indies. The contamination has raised concerns about the safety of locally grown food and the long-term health risks associated with Chlordecone exposure.
It's heartbreaking to think about the families who rely on the land for their livelihoods, and who might be facing uncertainty and worry because of this contamination.
It is, and it's a stark reminder that the decisions we make, even those made with the best of intentions, can have ripple effects that last for generations. The legacy of Chlordecone is a stark reminder of the need for careful consideration of the chemicals we use and the potential consequences of our actions on the environment and on human health.
It really makes you stop and think, doesn't it? This invisible chemical clinging to the soil for centuries really serves as a powerful message about our interconnectedness with the planet and the responsibility we have to be mindful of the choices we make. This deep dive has been a real eye-opener and leaves me pondering the unseen consequences that might be lurking from our past actions. What other chemicals might we uncover in the future that have a story like Chlordecone's? A story that unfolds over decades or even centuries. That's something to think about. Thanks for joining us for this deep dive.